Hello everyone, welcome to Automobile Engineering class. I am V. Rakesh, Assistant Professor in Mechanical Engineering Department. In this session, I am going to explain axial systems in automobile. Axials. An automobile with four wheels has two axials, one is front axle, another one is rear axle. The front axle support the wheels axles at the front. Similarly, the rear wheel serves as a support for the rear wheel's stub axles. The rear axle is absent on automobiles with front engine front wheel drive. In the rear engine rear wheel drive arrangement, the front axle is absent, but both axles are required on vehicles with front engine rear wheel drive and four wheel drive. Axles are divided into three types. One is front axle, second one is stub axle, third one is rear axle. Let us discussing about front axle. Let us see this figure. This figure shows front axle and its components. The front axle uses to carry the weight of the front part of the vehicle as well as to facilitate steering and absorb shocks due to road surface variation. The rigid front axle, which is nowadays used in heavy commercial vehicles, it is totally out of vogue on passenger cars and other light vehicles. It is made of I section in center position while the ends are made either circular or elliptical with the construction. The front axle is thick, strong and articulate structure member made of forged steel. The ends of the ends of the front axles are shaped to carry the stub axle of the ideal front wheels. The front axle carries the suspension system, suspension springs on spring seats. The the fork end of the steering knuckle accommodates and hold the ends of the front axle with the help of kingpin to reduce rubbing of lower end of the axle. On the lower end of the steering knuckle fork, a bearing is provided between these two surfaces. The kingpin is locked with the front axle end and does not rotate relay to it. The steering knuckle support the wheel assembly. The front axle acts as a simply supported beam and takes part of the vertical loads that is static and dynamic during travel. Normally, in all modern cars and medium automobiles, all wheels are braked. In such a case, front axle is subjected to horizontal loads during braking and should be strong enough to withstand vertical as well as horizontal loads. The cross section of the front axle should be rectangular and at best circular or hollow cylinder for taking care of twisting moments also. It takes bending loads and also torques due to braking of the wheel to keep the low chassis heights. Its center portion gives a downstep sweep. Sometimes it also transmits the torque from differential to the drive wheels. The necessity of front axle. Front axles are necessary to carry and to support a part of vehicle weight and facilitate steering and absorb road shocks as well as torque applied to due to braking of the vehicle, and sometimes it transmits torque from differential to the drive wheels. Next topic is stub axle. What is stub axle? A stub axle is a stub assembly of a front axle beam upon which the road will mount. Stub axle is connected to the front axle using kingpin. These stub axles turn about the kingpin, which is light drive fit in the axle beam eye located and locked by the taper cotter pin. Let us see the types of stub axles or front axle wheel axle connections. These are classified into four types. One is Elliott stub axle, second one is reverse Elliott stub axle, third one is Lemoine stub axle, fourth one is reverse Lemoine stub axle. Let us brief discussing about each stub axle. First one is Elliott type stub axle. Let us see this figure. Here this is the stub axle, this is the front axle. Both are connected with the help of kingpin. This type of stub axle is attached to the front axle by placing it in the yoke end with a kingpin and a quarter joint the two together. The swivel pin is usually fixed in the stub axle, forging with purpose turning in the forced closing of the axle beam. Axle beam forms as a yoke and receives stub axle. The thrust washer placed at the top portion of the stub axle. Second one is reverse Elliott type stub axle. In this, thrust washer is placed at the bottom of the axle beam. The reverse Elliott type stub axle form the fork end to receive the front axle beam. The front axle end forms eye and thrust washer placed at the bottom of the front axle beam, that is at contact face with the stub axle. The cotter pin in the joint that lock the movement of the kingpin in the front axle. The kingpin is free to move in the Pasper bronze bushes placed in the eye of the fork end. The thrust washer takes vertical load in the joint and it's used to increase the life of the both stub axle and front axle. The stub axle the stub axle forms as a yoke and receive the front axle beam. Next one is Lemoine type stub axle. The front axle beam, see here, this is the stub axle, this top one is the front axle beam. The front axle beam end form the eye to take support the stub axle. The stub axle and kingpin integrates to create reverse L-shape assembly receive the front axle. Here the thrust washer placed between the stub axle and front axle beam. Here the cotter pin in the joint is used to lock the front axle in position. The kingpin is free to move in the bushes placed in the eye of the front axle. The thrust washer takes the vertical load in the joint. Last one is reverse Lemoine type stub axle. Here this is the stub axle, this is the front axle beam. The front axle beam ends forms eye to take the support the stub axle. The stub axle and kingpin integrates an inverted L-shape assembly to receive the front axle. Here the thrust washer is placed at the bottom of the front axle. The cotter pin in the joint used to lock the front axle in the position. The cotter pin is free to move in the bushes placed in the eye of the shaft. The thrust washer takes the vertical load and it increases the life of both the stub axle and front axle. Next topic is rear axle. The rear axle is also termed as back axle. In a front engine rear wheel driven vehicle, the back axle is in two halves. Each has an output shaft from the differential. This is the left half, this is the right half. This these two rear axle connected to the differential gearbox. The differential casing is integral with the back axle, which encloses the two axles extending up to the wheels. The back axle casing, which is thick and hollow, supports the weight of the vehicle at the rear end with the help of coil springs or leaf springs and shock absorbers. Coil springs are used in light vehicles, leaf springs are used in heavy commercial vehicles. The rear axle casing is connected to the frame with two leaf springs, one at each other. Let us see the functions of rear axles. The main function is they support the weight of the vehicle. They drive the rear wheels via the final drive. They rotate the power flow at the final drive by 90 degrees on either side for driving the wheels. The rear axle casing, which is integral with the differential or the final drive casing, offers space for filling the lubricant for the final drive components. The rear axle casing serves as a protective guard for the rear axles, which extend from the differential to the rear wheels. These are the few functions of rear axles. Next, see the classification of rear axles. First one, live axle, dead axle, axle-less transmission, half floating rear axle, three-quarter floating rear axle, full floating rear axle. First one is live axle. A live axle is defined as an axle or shaft which rotates and transmits torque to the element rotating along with it. In the case of rear axle of an automobile, the rear wheels rotate on the live rear axles. Next one is dead axle. A dead axle or shaft is one which does not rotate, that means a dead position. The rotating element is mounted on a bearing on the dead axle. Example of a dead axle is the axle beam of front engine. Front engine, rear wheel driven vehicle. Next one is axle-less transmission. In this case, all the powered wheels and driven wheels of the vehicle are mounted on independent stub axles. Within each wheel, the stub axles are connected to the drive shafts from the differentials by means of a universal joints. The wheels are thus made independent of each other when the vehicle is in the motion. Next one is semi-floating axle. Let us see this figure. This is the semi-floating axle. In this, uh, bearing located on the axle and inside the axle casing, it has to support all the loads, as that is horizontal loads and vertical loads. It needs to be of a larger size for the same torque output. than any other type. The inner end of the axle is supported by the differential side gear. The outer end has to support the weight of the car and take end thrust. The inner end of the axle is splined to the differential side gear. The outer end is flanged so that the wheel can be bolted directly to it. In some design, the wheel, the hub of the wheel is key to the outer end of the axle. The vehicle load is transmitted to the axle through the casing and bearing, which causes the bending or shearing of the axle. The semi-floating axle is the simplest and cheapest of all other types of widely used on cars. Next one is three-quarter floating axle. Let us see this figure. In this type of axle has bearing placed between the uh, wheel hub and axle casing. That the weight of the vehicle is transferred to the axle casing and only the side thrust and driving torque are taken by the axle. This axle is keyed rigidly to the hub, thus proving the driving connection and maintaining the alignment of the wheel. The inner end of this axle has the same construction as that of the semi-floating axle. Although three-quarter floating axle is more reliable, is not as simple as the semi-floating axle. Full floating axle. A full floating axle has two deep groove ball or taper roller bearings located between the axle casing and wheel hub. The outer of an axle is made flanged to which the wheel hub is bolted. The axle is not supported by bearing at either end, and its position is maintained by the weight that it is supported both ends. Thus, the axle is reliable of all strain caused by the weight of the vehicle on the end thrust. It transmits only the driving torque. For this reason, it is called full floating axle. The axle may be removed from the housing without disturbing the wheel by removing the nuts. An additional advantage of this design is the ability to the vehicle even if it has a broken axle. This type of axle is more expensive and heavier than the other axle. It is usually fitted on commercial vehicles like trucks, etc. Last topic is loads on the rear axle. The vertical load at the wheel tends to bend the rear axle. The wheel load acts as a shear load on the aft axle at the wheel. The driving torque tends to twist the aft axle. The lateral loads or thrust on the wheel act as a axial tension or compression loads on the aft axle. The lateral forces acting as a couple introduce a bending effect on the aft axle. These are the few loads are acting on the rear axial beam. I hope this is very clear to everyone. Thank you for watching. Please do like and subscribe my channel for more updates.